Hello there, guess what we got in 1.19? We got mud. Now we'll find it not regenerating in the mangrove swamps. It has actually a use except somehow being used as decoration, because you can actually make it into clay. But how would you create clay out of mud? Well, first you will need a mud block. Then you will need something to place the mud block on, like this block, and then a dipstone under it. Then you just dry it like this. Then you just can break it, take the balls, and place another block. Let it dry like this again. But how would you even create mud in the first place? Because it is actually possible. First of all, you need stone. Now you would need stone, but not in your hand. You will need a smooth stone generator, like this. Then you lead it into another farm that will bone mill a moss block to make the stone into a moss block. Then you will need to bone mill the moss block again to make a sailor tree. Remember, it is only a 10% chance to get a regular sailor tree, but when you get it, you have turned the moss into rooted dirt. This process takes a lot of bone meal, but you can recycle the bone meal of the non-sailor tree things got from bone milling the moss block. You also get the wood as a byproduct, and that you don't need it, so you just need to get rid of it, so it doesn't stop the whole system. But then you take the rooted dirt and actually water it with water bottles. You may think that you will need to make it into dirt first, like this one does, but you don't need it at all, because the water bottles works on also rooted dirt, as we will see soon. We have now gotten mud. You would think that we will just dry it now, but the thing is, it is random, so it doesn't work. The thing is, I got the game 46 times like faster. Fast I mean random tick speed. That determines how fast things shall be updated and grow like crops and grass. But when you finish, you may remove it by explode it. But I have a solution to the problem. It is random. And this is my solution. You wouldn't get an automatic block stream into this, but you will get an automatic block stream out of it. It works by you manually just placing blocks like this, and when it dries, it gets pushed out. I made this 4 months ago, and I began the planning of this video 2 months ago. I wanted to release this video when 1.19 came out, but I was busy, so I couldn't be able to do that. When all are dried, this comes out and pushes it all. And what you want to do with it after that is your problem. Maybe blow it up into balls. This may look confusing and big, but it really isn't, because it's a thing here that you don't need. You don't need this part at all. It is just to make it more secure when you place the blocks. It is there so you can't place blocks when it is working on removing the clay blocks. So how is the steps to actually automate clay out of mud? Well, let's see. You would first of all need the blown mud block, then a place to dry it. The normal way to observe things happening in automation is an observer. So we will observe when the block has dried to clay. But we would also want to push it out, and that creates trouble with the block and the piston, and you have to, in the first place, placing the mud block makes trouble. So we would need a system that would not react when you place the mud, and then react when it has turned into clay, but not react when you push it out, and react. So it is really a 1 out of 4 signal. I tried to start with take it piece by piece, but it got too convoluted, and we want to have it high level. But then I remembered we can actually use a system that makes use of one ticking pistons. When it dries to clay, it reacts. The note when you push it out, it retracts. I place a new block, but when it dries to clay, it does. As said, my first attempt got too convoluted and confusing, and we needed to be tileable. So I made use of one ticking piston to make this second attempt. It works perfectly fine, just as you want it, and it is even almost flat. If you really want, you could make it even less visible, but you still got those. But I still thought it is too big. It is too much air inside it, so I wanted to compact it. But the goal is met. We have wrapped this thing around and back again. So I made this. This also works perfectly fine, just as we wanted. But I wanted to be able to maybe not have observers visible at top, and not have this pit that you would want to cover. And maybe I could make it even less air inside it. So I made this. It is actually a bit bigger, but it also works. But I after that thought that slime and honey can be difficult to get, and I didn't want the repeaters visible on top, sticking out like this. Other than that, it would be a perfectly flat version. Just to try another direction, I made this. As the last one here, it may use quarter connectivity. That this observer actually powers this piston. So I used this too. This is the smallest I could ever make, and it works. As long as you don't get the updates too quick to each other. But it's its own problem. it is actually not tileable, as we will see soon. Because the problem is, we need to get the signal from this end of the server to those piston with a too thick delay, or make a signal too thick in length, because the server gives a 1 tick pulse. We need 2 ticks, and I could only come up with using redstone. And but as we see, though they are not independent from each other, so it's a wrong way to go. So maybe this is the final version. I wish I could remove the observer, but still, maybe it works. So this is what I use on my half-automatic mud drying rack. But then we get to the next problem. After you have placed the mud and it dries to clay, then you need to remove the clay blocks automatically. So one way I figured out is using a piston worm. I wanted really to use something like this just horizontally, but I couldn't find a way. But the piston worm works. The idea is to have piston like this, and you give a pulses in the same direction you want them to go. For example, like this. So we just need to lead the pulses in the right direction. You have 2 ways here. One for the top, for the back. One for the bottom to out. And this is also why this is so lumpy and big, because we need to give a set amount of signals in the right direction to make this to go just the right way amount. But I couldn't make it to be totally reliable, so I had to use 3 blocks instead of 2 blocks to the standby position and a non-movable block just in case. The output, you get the output out here. What happens after this is your, as said, is your problem. This is full. It is therefore built up quite logically. And I said you don't need this. So how would you start to build it? Well, you would start with the core. First of all, you need somewhere to build it. And then you would need a block that you would want to dry the mud on. It is any block, as said before, any block that is whole. Yes. There you have the start. The mud goes on here. Then we need to observe the change, the drying happening. And then pull the signal down, of course. There are no action being made without pistons. But then we need to pick up the signal that we got from the observers and get them around, up again. And then get another one, like 1 tick piston extender with, of course, the 2 ticks repeaters, so it doesn't become any 2 ticks. If they're 1 ticks, as observers are, by default, these sticky piston will just spit out observers. We don't want that. So, as you see, when it doesn't react when you press the mud, but only when you okay. Well, then this is the default position. Yes, this is the default position. Or actually, this is not the default position. You could choose this one or this one. Doesn't matter. But I like having the repeaters not on top. It doesn't need to be half slabs either. No, yes. Yes, like this. Then we will need something that can read this. Noticing that this observer can tell if there are a block here or not. So if you just copy what this feels by placing a redstone component down here, and then observers here. Then we shall use cauldrons or other things, movable things that can store something that a comparator can read inside it, like this, to store if there are blocks there or not. Then we now need to combine all the signals to one signal. We're going to use something called a NOT gate. It's a simple idea that we have multiple inputs and then one output. Yes, like this. This means that both inputs need to be off or have a signal to this to turn on. And if you just add more inputs, the rule is the same. All inputs need to be on to this to be on. And we have it here. So if we just change what we're using for the inputs and how many, we then get we then get this. So as we see, there need all the clay blocks will need to be yes, pushed away for it to be on. But then when it is pushed away, we need to remove it. And as shown, I used a piston worm. So we will start with it actually, yes, right. This may be confusing, but we wanted to end it up like this. Keep in mind how far piston can push. They can only push 12 blocks, as we see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. As we see here, just can't. We need to count in this too. We can't this either, but on gray block 11, therefore 12 with the piston, it can. that also means that we can duplicate this further on. So let's do that. Then continuing with the piston worm, we know a way to give it pulses each direction separately. So we will start with the pushing part first. Away with these blocks, you don't need it. We would want to have it like this, not this, because then this observer will power this piston. We don't want it. So we are going to place a block here to have a signal travel to this instead. Then a way to make this signal be able to travel the whole way. And then another set of observers, but now going the other way. Yes. Like this. We now want to be able to get both signals from here. We already got this signal from here, but we need also this signal to come from here. So we will do that too. So I will start with actually placing a piece of rail. We would want to have rails the whole way because I think we would want the signal to go back here as fast as possible, and observers use one tick each block. Oh, okay, it works. We also need to connect this to this. But as we see here, rails don't reach the whole way, so we shall place a observer here, and then we have signal the whole way. Then we will begin with the clock that gives the pulses. Wow. And the timer clock. So either way, it is first those who try to give the signal further, and then the plane where the clock pulsing happens, and then the clock. This is the clock. And now we will need a way to control it. So we would then build the clock. We will start with a comparator facing like this, and then hoppers, and then we have a block here and a block here. Yes, where is my redstone dust? I shall steal this. Like this, and then a block up here, and with another redstone torch. Then we we will need 12 items. I found it to be very fitting for this. Then we need to get an output of it. With a redstone torch. And there we have it. Actually, let's test it maybe. So each time this gets pressed, of course we don't have the next circuit. That circuit is to control what direction it goes. But first of all, we need to connect this output from when it is ready to be when the clay is ready to be removed, and this clock to start process. this is a constant pulse, but we want a pulse. So we can solve it by simply building a monostable circuit with an item init and a comparator. Then we will just need to connect this up. Like this. Remember that we would want these two to connect. Why? Of course, like this. So each time this gets a pulse, this will it didn't work. Yes, like that. Each time this gets a pulse, and then the clock starts for some time before it stops again. Now we shall build the circuit that determines what direction we choose to go. The interesting thing is this block, this torch, gets powered for exactly half the amount that this comparator can read and output. And as we know, half of the time the piston shall push, and half of the time it shall retract back to the standby position. So we can take advantage of that. So we then get an output from this. Understand. And remember to not make those two connect each other, and have a torch up there, and then the piston here with a block. Let's test it by replacing this torch. Remember something that can hinder it to go too far. Yes, it worked. Each time it gets a signal, it goes pushes, goes back to standby position. And that is really all. This is the whole circuit. Now, if you want to, you should make an automatic way to remove the blocks when they come. As said, this block piston can only push 12 blocks, so if you don't remove the blocks, it already stop and it can't take any more mud. I have now made a way for my crate to be removed. It can be difficult in doing it over distance, but since piston can only push 12 blocks, but The point is, you need to remove it and do something about it. Maybe explode it with balls. But that is all. If this video is early enough, I may actually have made more. So check out those if you want to. If then, that's all.